Alright. So let's start the class. Now the question to you all. What are we going to learn today? Any guess? No guess? Yep. Something about quadratic equation. Hello, Sarah. Yep. So we have Alekha, a child whom I have not interacted with in the past, or if I did, I probably forgot. Alekha, do you want to introduce yourself better? Is this your first class? Hey Vishal. So there is a child with name Alekha Ponakanchi. Do you want to say hello to everybody? Okay. Alekha is not comfortable saying hello even. Alright, let's do one thing. Let's quickly do a roll call. So we have Alekhya, Chris, Neil, Nikhil, Purvi, Rehan, Priya, Sahit, Sara, Saranya, Tansi and Vishal. And here in the classroom we have Praneet. And with Sahit we have Daivik and Arush both. Alright. So Alekha dropped off, she will join some time. Alright, so as I was asking, what are we going to learn today? So my obvious response to you guys would be that we are going to learn about quadratic equations, and that is something that you guys have learned a couple of times from me. So that might sound like a boring concept, but that is not the goal. The idea is not to get you guys bored. What we'll do is we'll touch upon some of the interesting facts about solving quadratic equation, and then we'll go on to system of linear and quadratic equation. So that is where we will combine these two concepts together and see how we go about solving problems relating to these two concepts. Does that make sense to everybody? I mean, is that okay as a starting point?
Yes, sir.
Okay. Now, let's, and again, in yesterday's class we talked about isolating quantities. That is where we talked about we dealt with some word problems relating to isolating quantities. So, anything and everything that we will do with equations, that will have some flavor of isolating quantities for sure, because ultimately when you are dealing with equations, you are trying to solve the equation, you are trying to isolate the variable that you are trying to solve for, and then use some of the basic techniques for solving it. Yeah. So let's start with quadratic equation in the first place. So any quadratic equation that you guys would have heard about in the past or would have gotten tired by now is in the form of this: x squared plus bx plus c equal to 0. This is a very standard form of any quadratic equation. Everybody with me so far? No contention with what I'm writing on the board? Okay. Alright. So let's look at, if you have to solve this quadratic equation, you guys know that ultimately your objective is to find out the possible values of x. If you're talking about a quadratic equation, you will end up having up to 2 solutions for every x. Or if it's a quadratic equation written for y, let's say 6y squared plus 8y plus 9 equal to 0. When you solve this, you are actually solving for the variable y. And you can get up to 2 solutions for this. That's a basic understanding we all have to have when it comes to quadratic equation. So you can have up to 2 solutions, you can have 1 solution, You can have no solution also, depending on what kind of a quadratic equation you're dealing with. Yeah. So this is the standard form. Now, if I ever look at solving any quadratic equation, let's say 5x squared plus 2x plus 9 equal to 0, and I say solve it for x, you guys have three methods for solving it. One is by, hi Dhanushree, I saw one more child join in between, and her name is Varshini Vipala. Hi Varshini, you are one of, so that is where I get confused. So if you guys join with some other name, that gets me a little baffled with respect to the name. So sorry about that, Varun. So now I will not call you Varshini for sure. Okay. So when we talk about a quadratic equation, there are three methods of solving it that you guys are already aware of. If anybody has any doubt, we'll anyways come back to that in future as well. One is you try to map it with one of the standard formulas and see if you are able to break it down into something like x plus a into x plus b, something like that, or x minus a. A and b could be positive or negative depending on what we are dealing with, but we are trying to factorize that using all the standard formula. That is one approach. Second approach is you try factorizing that by using a and c, you multiply a and c, the coefficient of x square and the constant, you multiply them and then try breaking the b. That is the second option, solution approach. And third approach is you are solving with the quadratic formula, which says if this is the thing, you will say minus b plus minus b square minus 4ac by 2a. So this is the third approach. And I'm assuming that you all have dealt with this in the past, so I'm not going to that. I'll come back to this whenever we need to. Okay. So there are three approaches for solving a quadratic equation. Are we going to do a repeat telecast of that? Probably not, unless somebody has any particular doubt on this. But we are wanting to look at some more flavors of it. And the flavors are, as I mentioned, those are, let me read that for you guys. Solving quadratic equation using square roots, that is one. Second is using the zero product property and factoring quadratic equations. And third topic that we are going to cover is going to be dealing with system of linear equation, quadratic system of equations. So the two methods are that we will cover apart from what we discussed is using the square root formula. How do you find out the square root of straight away from the quadratic equation? Am I going too fast? Say yes. I can correct it. It's okay. No? Okay. So we are going to cover, apart from three methods that we have for solving quadratic equation, there are two more things that we are going to cover. One is called the square root approach. Second is called finding out zero factor. So let's look at the square root approach. Okay. Let's say I am dealing with a quadratic equation. Let's say 5x squared minus 3 equal to 22. I have a quadratic equation like this. So if I have to solve this equation, is this in the quadratic equation form in the first place? Any guesses? Is this in the form of quadratic equation? I'm sorry? Okay. Yep. Yes, I said no. You said no. So I heard from Sahib and Pradeep that this is not looking like it's in the form of quadratic equation. So I have to move this guy here. Now what I have is 5x squared minus 25 equal to 0. Is this in the form of quadratic equation right now?
No.
No?
Yes.
Sahib?
No.
No?
Yeah.
David says, yeah? Vishal, any thoughts?
Yeah.
It's a quadratic equation? Okay. So, yeah, the answer is yes, this is in the form of quadratic equation. Why? Because, see, when you have a quadratic equation, the standard form of a quadratic equation is ax squared plus bx plus c equal to 0. Now, some of you might be thinking that this is not the form of a quadratic equation. Actually, it is in the form of quadratic equation. Why? Because two things. One is, any equation will be called a quadratic equation if the maximum power to the variable is 2. I have a variable which has maximum power 2. So that is the first criteria that is met. Now, what is making you guys think that this is not a quadratic equation? Probably because you are trying to say, okay, I have x squared thing, I have a constant thing as well, but this is missing. This is not the criteria for this to be called a quadratic equation. This is a standard form. But is this not a quadratic equation? Yes, it is a quadratic equation. Why? Because the maximum power is 2, and the way you can assume this is like this: plus bx minus 25 equal to 0. Now this is looking like quadratic equation. Interestingly, the value of b is 0. That is why this was not visible in my earlier equation. So even if I have this as an equation, I can still claim this to be a quadratic equation. Hello, Saranya.
Hi, sir. Sorry, sir.
No worries about it. So we have not used anything so far. So we have gone back to quadratic equation, and we are trying to find out one special flavor of quadratic equation. So I gave this question that, okay, if I have 5x squared minus 25 equal to 0, is this a quadratic equation? We had some difference of opinion in the class where some of us felt that this is not a quadratic equation. I am saying no, it is a quadratic equation still, because you have that bx here. Only thing is the value of b is 0. That is why you are not seeing the x term here. But the maximum power to the variable is still 2. So it has all the reasons to be called a quadratic equation. Do we all agree now? Yeah? Varun? Dhanushri? Rehan?
Yeah.
Purvi with me?
Yeah.
Okay? Alright. So see again, every problem that we come across, right? Be assured that every problem, the solution approach would be the same, just that some of the time we'll have to interpret that with a little bit of a different thinking process. Okay? So now everybody agreed that this is a quadratic equation. So now if somebody has to solve for this one, solve this quadratic equation for the value of x, that is going to be fairly straightforward, right? I can say this equation is same as, because I see 5 being common, or I can say, yeah, so this equation becomes this for me, because I always have a flexibility of dividing each and every term of the equation on both the sides by one number or any number of our choice, and that doesn't change the overall behavior of the equation or the property of the equation. David, are you with me?
Yeah.
Yep. Nikhil, no confusion, right? Alekhya, any doubt with that?
Yes.
Okay. So this is my new quadratic equation. If I have to solve for this is what I will do. X square equal to 5. So that means x equals the square root of 5 plus and minus. That becomes my solution. So this is one flavor of a quadratic equation where you can find out the value of x by doing the square root alone. Okay? By doing the square root alone. And when you can do that, when your b term is missing. When your term with the x coefficient is, when your term with the x is missing in the quadratic equation. Meaning, when you have x square term and a constant term, and you have nothing here in the middle place. That is when you can use the square root method for solving for the variable x in a quadratic equation. That was one of the flavor, right? So because see what will happen is if you ever had to solve, let's say, a quadratic equation 2x squared minus 3y plus 8 equals 0 versus x squared plus 14 equals 0. X squared minus 14 equals 0. When you are solving for this guy, you have three methods for doing it. You can apply quadratic formula, you can look at factorization options, or you can try mapping that with one of the standard formula for a plus b whole square, a minus b whole square, or a square minus b square. But when you have a situation like this, you don't really have to worry about all those three methods. You can use the square root method to solve it real quick. Yeah? So this is another method. So basically, as soon as you get a quadratic equation to solve, the first thing that you have to look at is, do I have all the three terms, or I have only two terms without the x part? Okay? If I don't have the x term, I can straight away solve it using the square root. So that is a method called square root method. You guys would solve it for sure by yourself, but I'm saying sometimes what happens is, if you don't take the method into consideration, right, you might end up taking the longer route and solve for it. That will probably unnecessarily waste a couple of minutes for you, which you certainly don't want to do in the exam. So this is another thing that you have to look into or take into account when you are trying to solve it. Look at the quadratic equation. Is it a quadratic equation? Yes. Do I have the x term or the term with a single power of variable? No. I can straight away jump onto the square root method and solve it. I don't have to worry about the other three interesting methods that we are aware of. Is that clear? Alekhya, Nikhil, Rehan, Dhanushri, Varun, Sahit, everybody?
Yes, sir.
Yep. Okay. Purvi,
Yes, sir.
Dhansi, no worries? No. So by now you guys would have realized, right? I have the habit of nagging everybody, and that's my method to just make sure that everybody is with me. I'm not rushing way too quick, only keeping one or two of you in mind. Okay? We shall no doubt, right, beta?
Yeah.
Okay. So this is called the square root method for solving a quadratic equation, apart from the three methods that you guys already knew. And the next one that I'm going to talk about before I jump onto the next topic is about the method of multiplication of 0. And trust me, there is nothing new. Again, I'm probably going to waste 10 minutes of everybody's time by talking about that method, but there is a little bit of merit in that, just for all of us to be on the same page. Let's say if I'm trying to solve x squared minus 8x plus 16 equals 0. Okay, so you will simplify. This is x squared minus 2 into 4 into x plus 4 squared. So this is a squared minus 2ab plus b squared. So it's a minus b whole squared. So x minus 4 whole squared equals 0. That becomes x minus 4 into x minus 4 equals 0. This is one problem. Now let's say if I had a problem like this, x squared minus 9x plus a, okay, equals 0. That I have to solve this one. So this is not in the a plus b whole square, a minus b whole square form, because this is not a perfect square. So we'll look at the second method of factorization, where this is my a is 1 and my b is minus 9 and my c is 8. What I do is I multiply a and c A into C is 1 into 8, which is equal to 8. Now I have to look at how do I break 8 into 2 pieces, which gives me this one. So I can do I can do 8 into 1, which is 8. Now if I add 8 and 1, that gives me 9. So can I say minus 8x minus x? I'm just breaking this into 2 parts. So it becomes x square minus 8x minus x plus 8 equals 0. I'll take these two together, So this becomes x minus 8 and here minus 1, x minus 8 equals 0. So this gives me x minus 1 into x minus 8. All that I was doing is something that you guys already know. I had this equation to solve for x. I found this is a perfect square. I tried relating that with the standard formula. I found that this is my standard formula that it relates to. I had a situation like this, an equation like this to solve for x. This was not a perfect square, so I used the factorization method where I multiplied a and c. I got a, 8, and I am trying to break 8 into 2 parts such that I get a 9. So 8 factor of 8 is 8 into 1, 2 into 4. I am not interested in this. This one is enough for me. 8 in 1 makes it 9. So I use that for breaking 9x into minus 8x minus x. That is 9 minus 9x. And then it gave me this factor. So in both the scenarios, whether we use the standard formula for this or whether we use the method of factorization, ultimately we landed in this situation. Both the equations have been transformed into factor form, or they have been factorized. This is using a different method, this is using a factorization method. Now, once we come to this is what is called zero factor method. So when you factorize your quadratic equation into this form or this form, eventually what you have? Something into something equal to 0. Something into something equal to 0. So from that, what you are concluding is, something into something is 0, meaning either this is 0 or this is 0. One of them have to be 0. That is how my end result is going to be 0. And here, in this case, both are same. So you are saying x minus 4 is equal to 0. That's the only way this value of this whole equation can become 0. That's the only option. Is that making sense to everybody? Saranya, with me, beta? So we have two Saranyas in the class. No, we have Saranya and we have Shravya. My bad. Only one Saranya. Okay. So here, the crux of what I'm trying to convey to all of you is that this is called the zero factor form, meaning you have factorized your equation. Now one of the thing is 0. That is how your overall result is going to be 0. And that gives you the clue to find out the answer for this. In this case also, we have two factors. One of them is 0, or maybe both of them. 0 into 0 is also 0. So that gives you the clue with respect to what your solution could be. In this case, you had only one option because this was a perfect square. So you had only one option. This one says, okay, either this part is 0 or this part is 0. X minus 1 is 0 or x minus 8 is 0. So that is how when this is 0, when x minus 1 is 0, x is 1. When this is 0, meaning x minus 8 is 0, x value is 8. So nothing new with this concept, but whenever you hear about zero factor form or something, don't think that's a new concept or something that we have not learned. This is the extension of the same thing that we have learned with respect to how do we solve quadratic equation. Okay? It's just given a different term. So basically when I was going through the syllabus for you guys for today's class, I was thinking that, okay, is this something that is worth teaching? Not really. Because this is something that you guys already know, as long as you are aware of how do you solve quadratic equation. But then, would it get you guys confused at times? It might, because if you have not learned it the way it is called, then you might think that this is a new concept which you are not aware of, and then you might follow a different path which might not be correct. Yeah? Everybody okay with that? Now, based on whatever we have seen so far, let's look at solving few problems, and then we will see how do we go about it. Okay, so let's look at let me pick up some of the problems that we will solve together and see if we are on board with respect to solving things. So there are a lot of problems that I have posted for covering in the class today, but we will not try solving all of them. We'll just try getting our point of view around those problems and see how comfortable and ready we are when it comes to solving the problems. So let me write the question first. The question is 4x squared equal to 52. What are the solutions of to the equation above? And there are four options. X equal to 13 is option 1. Option 2 is x equal to minus 13 and x equal to 13. Third option is x equal to square root 13, and fourth option is x equals minus square root 13 and plus square root 13. So these are four options, and trust me, I don't want anybody to solve this. Yeah, okay, I got one answer. So for this problem, right, when you look at this problem, what is that comes to your mind based on what we have discussed today? Anybody? This is a quadratic equation for sure, or you can convert this to a quadratic equation 100%. And this is you can use the square root formula, correct? Square root approach, because there is no x term. Now, without solving for this one, can you guys tell me what will be your answer in 10 seconds? I got one answer in 10 seconds. Yeah, Vishal.
D.
Louder.
D.
D as in David?
Yeah.
Okay. David?
It's C.
C. Okay, this is one. This is one. I got 2 votes here.
I got D.
You got D?
Yeah.
Okay. How about you, Nikhil?
D.
D. Okay. Tansi? Dhanushri? Sorry, beta?
I got D.
You got D. Dhanushri? Urvi? Give me the answer without solving it, okay?
Can I change my answer?
100%.
I think it's B.
Louder.
B.
B as in boy?
Yeah.
Okay. Okay. This also has one option. Okay. Yeah, Vishal.
Was on D, is it negative square root 73?
No, it's negative square root 13 and square root 13.
Yeah, I was just making sure.
Okay.
Wait,
That-
I want to change. Never mind, yeah.
Now you have to tell me what you are leaning on.
I think it's C.
C as in Charlie.
Yeah.
Okay. Okay. Yeah, dear.
I think it's B.
B as in boy.
Yeah.
Okay. So you guys, some of you like the first character of my name as well. That's good. All right, Nikhil.
Yes, sir.
Yeah. Oh, you had raised your hand. I thought you were going to change your answer.
Oh, yes.
Okay. Purvi.
I think it's D.
B as in Birendra Kumar.
No, D.
D as in David.
Yeah.
Okay. All right.
Server.
Yeah, it's D.
Is it negative root 13 and positive root 13?
Yes, sir.
Yeah, I got D.
You got D.
It's D.
D.
I'm not again.
Okay. Okay. Changing your mind. Okay. That's okay because I was. Yes.
Oh, that was fast.
Okay. So I'm relying on everybody's mind. I'm not asking anybody to solve this problem. And this problem can be solved in less than 30 seconds or maybe 20 seconds. Shravya, your answer, beta? What would be your choice? Sorry?
I think it's D.
D. D as in David?
Yes.
Okay. Alright. Varun, any thoughts?
I think it's C.
It's C. Okay. So here's the thing. I was not wanting you guys to solve. I was trying to see how do we apply basic. I would not use the term intelligence because that scares me. I will use common sense to solve it. And again, there is no option that is incorrect. It's just about how we are approaching it or how we are thinking about it. So a problem like this, for all of us, the way to solve would be, okay, is this a quadratic equation? Yes, it's a quadratic equation. It can be converted to a quadratic equation. Neil, your answer, beta? Sarah is coming and going, but Neil, what will be your answer? D. Okay. So, okay, let's look at it. I'm not solving it. Trust me, I'm not going to take out the cap of my pen. Okay, I'm going to solve it without solving. So this is a quadratic equation for sure. Now I have a 4x square equal to 52. I have to isolate things. I can use the square root method, but I can do square root only when I have only x here. Meaning I knock off this guy. And how do I knock off? Butterfly method. This guy goes down. 52 by 4 is 13. 13 4 is 52. So x square is 13. When I do a square root of 13, I get two answers, or I can get two answers. Plus square root 13 or minus square root 13. Square of both gives me 13. So I am talking about square root of 13. Okay. The square root of 13. So that can give me plus or minus both. Okay. So that is how this is my option. I would not stop here because we know already, right, that if we have to, Mandeep, why are you joining level 3? You will be overwhelmed. Join after 20 minutes, but okay, you're early. So we know that whenever we do a square root of a number, we can get two answers. Square root of positive of that number, square root of negative of that number. So that's why we had two options. We can get tempted to stop here because okay, square root of 13. But eventually, square root of 4 also gives us plus and minus 2, because when you square plus 2, you get a 4. When you do square of minus 2, then also you get 4. So that's why we should make sure that we are not ignoring that part. Yes, David?
But if you put negative in front of the square root's already going to make it plus or minus. So if it's a plus, then it'll make the plus a negative. And if it's like, it's like you're multiplying it. Oh wait, yeah, that would make both positive because you would have positive.
Okay, so this is an interesting discussion. Yeah, you are saying
But
something.
never mind.
So when you square
The negative.
when you square a
I
negative
thought
number,
it was wrong.
guiding, when you square a negative number, it's the same thing as squaring a positive number because negative times negative equals positive.
Alright, so here's the thing. Okay. Now, so David, I mean, whatever you argued, that is not a bad argument. Trust me, we can get confused at times. If I have x equal to x square equal to 13, I am tempted to say, okay, x will be equal to, so I am doing a square root here and I am doing square root here. Right? That is how I will get a x. So x gives me square root of this. But I will get plus 13 or minus square root 13, because if I do a square of this, it gives minus into minus square root 13 into square root 13. Okay, this gives me this 13 minus into minus plus. But if I put this as x equals minus 13 inside, okay, in that case, what will be my x square? X square will be minus 13 square, and the square of that will give me minus 13. So that is where a little bit of hindrance could lead to a different answer. Yeah? So your minus has to be outside the square root is what I'm trying to say. Does it make sense to everybody? Yeah?
Yeah. Sure.
And don't suppress any of the doubt. If there is a doubt, I am okay to argue with you guys for another 5 minutes. That's fine. Make sure that you don't assume because I'm forcefully asking you guys to be in agreement with what I'm saying. Okay? So, crux is there is a difference between minus 13 versus minus 13. This is a real number. This is imaginary number. Yep. Okay? Alekhya. All okay, beta?
Yes, sir.
Okay. Shravya, with me?
Yes, sir.
Shravya used to be with me in the classroom, but she is not with me anymore. She is joining online only. No, I'm just kidding. Okay. So Shravya came first class. Your first class was in person, and then it has been online since then. Same was the case with Tansi and Alekhya also. Few classes in person, then online. But I would suggest whoever is wanting to come in person, you can probably wait for a month and a half till the summer gets little more pleasant. Okay, it's little hot. I have put on AC and all in the classroom, but it's still not as comfortable as it could be at home. Alright, so we looked at one problem and we found what all problem we could come across. Let's look at another problem. Again, we will not try solving it. I will probably rush through that real quick so that we can spend some time with the next topic that we want to pick up. The question here is x plus 3 into x minus 5 equal to 5. What are the solutions for the equation above? Option A is x equal to minus 3 and x equal to 5. Option B is x equal to 2 and x equal to 10. Option C is x equal to 1 minus 2 root 5 and x equal to 1 plus 2 root 5. Option D is x equals 1 minus square root 21 and x equal to 1 plus square root 21. I will not try solving it, but without putting a lot of effort to solve it, what is the option looking like for you guys? I just need 2 of the quick answers on the screen and one in the classroom, and then I'll try solving it. Yes, Vishal?
I think it has to be one of C or D.
One of C or D? No, unfortunately you will not have that option in the exam. You have to tell me either C or D. Be it right or wrong. So Vishal, you have to choose which one you want to lean on. Yeah, David.
I think it's D.
D.
D, yeah.
D as in David?
Yeah.
Okay. Yep. Yeah, Varun, go ahead.
I also think it's D.
D. Okay. You also think it's D? Okay.
D.
Vishal thinks D. Okay. Okay. Yeah, yeah.
So,
I'm sorry, Vita? It's D. D as in David? Okay. Nikhil?
I think it's D.
D. Okay. So here's the thing. This is how we'll go about it. Now, I'm not solving it, okay? I'm going to rely on my instinct. First of all, x equal to minus 3, x equal to 5. If I assume this was 0, that would have been my answer. X equal to minus 3, but this is not 0. This is 5. The best I can do is divide everything by 5 and I have 1 here. So this is not the case for sure. Something to something equal to 0 versus something to something equal to 5 are 2 different situations. So this one is ruled out. Okay. Now, another thing is x equal to 2, x equal to 10. How is that possible? This doesn't look to be the case to me, straightforward, okay? I'm not going there right now. When I break this down, what do I get? I will get x squared plus 3x minus 5x. So it's something into something. I'm exploding the factor into normal equation. It becomes x squared. It will be plus 3x and minus 5x. So plus 3x minus 5x, and this becomes 3 into 5 minus 15 equal to 5. So what I'm going to have is x squared minus 2x minus 20 equal to 0. This is the quadratic equation that it will translate to. Okay. So if I have to solve this one, the best option we have is quadratic formula. And if you look at this whole thing, this one, what is my b value? B is what? Minus 2. And if you relate it with the quadratic formula, right, I am again not trying to solve it, and without solving it I am trying to get to a, what is my this thing? B square minus 4ac. B square minus 4ac. B square is what? 4 minus 4 into 1 into 20. 4 plus 20, 24. This is square root of 24. Which one gives me b square minus 4ac. 4 minus 4 into 1 into 20. So 4ac minus 20. So this became 24. So this 24 becomes, if I do a square root, this square root of 24, it becomes 2 square root 5. Because 4 into 5. No, what I am doing here. Did I put the question correctly? Did I? 1 minus 2 root 5, 1 plus 2 root 5, 1 minus square root 21, 1 plus square root 21. Did I miss something? X squared plus 3x minus 5x. So minus 2x, 3 into 5, 15, minus 15. Yeah. So, okay, the square root of 24 gives me 6 square root 2. How you guys are thinking that it's option B? I am not finding any option that is matching with this one. Is it square root 5 or square root 6? Let me just look at it. No, it's square root 5. Okay, then I have no other choice but to solve it, okay? You got D as well, right? How did you get that?
I did this and I brought it into the quadratic thing,
Uh-huh.
and then I used like the quadratic, like I tried to factor this one, and then I don't know if I just used the quadratic.
Okay, so this is the equation, right? This equation is fine. This is what you would have got.
Yeah.
So now let's solve this, okay? Let's solve this. So if I have this x square minus 2x minus 20, my two answers here would be x equal to minus b, minus into minus b, plus minus b square. B square is 4 minus 4ac. 4 into 1 into 20. Okay. I was making a mistake here. 4ac, c is 20 by 2a, 2 into 1. So this becomes 2, x equals 2 plus minus 4 plus 80, 84. This is 84. I was somehow getting 24. My bad. So this is 4 times 21. Okay. So everybody got B, right? So yeah. No, my bad. What I was doing was, when I was doing B square minus 4ac, I was not looking at this as 20. I was looking at this as 5. That is how I was getting 20 plus 4, 24. And I was getting stuck. So this is actually, by C is 20. So when I multiply that, I get a square root of 20, 84. And square root of 84 is 2 times square root of 21. So my value becomes 2 and 2 times square root of 21, and then 2 is common here, so it becomes 1 plus minus square root 21. Yep, okay. Guys, practice is very important. So if your teacher is not doing practice enough, it could go wrong. And see, why I was getting stuck here. I was looking at this as 20, but in my mind I was calculating this as 5. And that is how I was getting plus 24. And none of the options were matching. So basically, but I could figure out by going through the steps, right? I could at least make out, okay, was my equation right? Okay. Did I put the quadratic formula correct? So it all comes, one takeaway from this is that if you get stuck, if you do a wrong calculation, as long as you are taking care of the steps one by one and you have a way to trace it back, you will be able to find where you went wrong. Yeah? Everybody got frustrated with me today? No? Okay. So this is a very normal situation, okay? Everybody comes across this kind of problem, okay? When you're trying to solve a problem, it's not that you'll always pick the right approach or do the right calculation. So when you're doing your scratch work to find out your answer, because when I was going to this one I could rule out, but this one was not very clear. So I could not nail it down to this option. Then I was saying, okay, let's see, these are very clear, straightforward. These were not clear, straightforward. So then I said, okay, fine, let me break down the equation and then see what it comes down to, and then I can apply what is my fastest technique. And that is where I got stuck. So I could decode where I was going wrong and we could come back to this option. I will not choose an option just for the sake of choosing unless I'm convinced about it. And that's that's something holds true for all of us. Yeah? Okay. So these are some of the equations related to quadratic equation or solution of quadratic equation using the first problem that we solved, that was the square root approach. This solution that we looked at, that was a factorization approach. It was already in the form of a factor, but this was a little misleading. If we are in a hurry, we might say, okay, something to something, oh, I got the answer. But if you overlook this one, then you might miss that. But so you have to use a couple of techniques. One is how you can eliminate the options so that you improve your chances of being right. How soon you can eliminate some of the options, and then you have to look at what is the fastest method you have for solving it. Yeah. Okay. Now let's jump on to the next topic. I'm not wanting to bore you guys further with the quadratic equation problems because we have dealt with that enough. Now let's look at something a little different. All of us have dealt with system of linear equations, right? Nikhil, you want to say something? You have raised your hand.
Sorry, sir, I didn't.
No worries. So what I was saying was, all of us have dealt with system of linear equations, right? Can I hear a confident yes? Yeah.
Yes, sir.
It's very simple, right? If we talk about a linear equation, we are talking about equation in the form of this, where the maximum power to the variable is 1, and that apparently draws a straight line for us. So if I have a linear equation, let's say 2x minus 3y plus 11 equal to 0, if I try drawing that on a coordinate plane, it might draw a line like this, or a line like this, whatever it is. Similarly, so this is one linear equation. What I mean by system of linear equation, meaning when I have multiple equations, let's say another equation I have is 3y minus 2x plus 7 equal to 0. This might draw another line which may interact or intersect the other line at maximum one place. So if I have two linear equations that eventually draws two lines separately, they could either, there are three scenarios that we can talk about. One is both the lines will overlay each other, or they would be parallel to each other, meaning they will never intersect, or they will intersect at one point. So there are three options, three scenarios that we can come across, right? I'm not going to talk about solving linear equation right now. We will come back to this topic depending on public demand. But for now, I'm assuming that we all know when we have system of linear equation, when we solve them, we can get one solution, meaning when both the equations or both the lines meet or intersect at one point. We can get zero solution when they don't meet, when they are parallel to each other, or we can get infinite interaction points or intersections if they are overlaying each other. Essentially, this is a situation that you will deal with when you are talking about equation like 4x plus 2y equal to 8 and 8x plus 4y equal to 16. Both are actually same equation, okay? That's why here you can see that if you take 2 common, it becomes 4x plus 2y equal to 8. So this equation and this equation are the same because you have just multiplied this equation by 2. And this eventually, if you try drawing this line and this line separately on the coordinate plane, you will see that they are overlaying each other. They have infinite number of intersection points. Yeah, both are same line actually. Now we are not going to talk about system of linear equation today. What we wanted to talk about was we talked about quadratic equation. We all heard or we know that okay, if I have a quadratic equation, draw a parabola. It could draw like this, it could draw like this, it could draw like this, it could draw like this in a coordinate plane. Any quadratic equation draws a parabola for us. Now, if I have a combination of a linear equation and a parabola, what are the possibilities we are talking about? If I have, let's say, a quadratic equation x squared plus 6x equal to y, okay, and a linear equation saying 3x plus 2y equal to 7. What are the possibilities we are talking about? I'm sorry? At least two intersections? At most. So the concept that I wanted to kind of bring to the table with you guys is, if I have a quadratic equation like this, okay, let's imagine this. It draws a parabola first, it's like this. And I have a linear equation like this. It draws a straight line like this, or this, or this. There are three scenarios in this combination also. When you have a quadratic equation and a linear equation, there are three possible scenarios that you could come across. One is when the linear equation cuts across the parabola at 2 points, as you can see in the picture, or it doesn't get anywhere closer to the parabola, so no intersections, no common points, or it could just touch the parabola at one place and run away. So when it touches at one place, there is only one intersecting point. When it cuts across the parabola at 2 points, there are two intersecting points, and when it doesn't cut, no intersecting points. Okay? So how do we go about solving this kind of problem? If you are given a quadratic equation and a linear equation, you have been asked to find out how many intersecting points it will have. How would you solve it? What are different thoughts that will come to your mind? So today we are not going to solve this problem. We will probably cover this with more practice in the coming class. But I just want to pick your brain to see how would you think about solving it. Yep.
Maybe like isolate the x value and like the near equation and substitute it into the quadratic.
Isolate the x value. Okay. Let's see what Davik will say. Yeah, Davik.
First, I would isolate the x value for the second equation, and then and then substitute that into the first equation.
Okay. Vishal.
Yeah, I was about to say substitution.
Okay. Now there's one more thing, and I'm pretty sure that you guys are. I mean, I'm not pretty sure. I'm convinced that you guys are thinking the right direction. But there's one more aspect that you would want to keep in mind. That let's assume that my linear equation or the straight line touches the parabola at some places. Wherever it touches, at that point, my x and y value for the equation and this one will satisfy this condition, right? Meaning, if it touches at these two places, let's pick this point. If this is the point where this linear equation and this parabola touches, this is one of the points, let's say. So that means the x and y coordinate of this point for this line and this parabola both will match. Meaning, whatever is my y value here will be the y value for this guy also. So, we can look at, say, to find this is my y. I will say from this equation, my 2y equal to 7 minus 3x, y equals to 7 minus 3x by 2. And you substitute this thing with here, and then you will try solving for it. As you guys said, right? This is, you will try using substitution. But what you have to keep in mind is, substitution is the right method, but there's an overarching concept that you have to be, that you have to keep in mind, that any equation that we have, there is an agreement between x and y. So is the case with this guy. When these two guys are meeting, that means there is a common agreement, there is a common x and y value wherever it meets, which satisfies this agreement and this agreement both. So you can pick any of them, be it x, be it y. It's up to us. Whichever is convenient for you. So you will have to find. Let's assume that this meets at one point. Let's find out. Let's say if x is easy for me, I'll go with x. If y is easy for me, I'll go with y. And then solve for it. That will be our approach. We will break our head with these problems more by doing more word problem and more interesting solution in the coming class. Okay? I will let you guys go. Enjoy the rest of your evening. I'll come back to bother you guys next Saturday.
I will be sure. Bye, sir.
Alright, bye bye.